But this is my status of embedded Linux presentation. This has been updated for January of 2025. I'm very happy to be able to give you an update of kind of what's going on with embedded Linux. Just by the nature of this presentation is I periodically take a look at the status of embedded Linux. This is not a comprehensive overview of everything. It's just some of the things that I saw. There's no way to cover everything, and I apologize in advance if I missed something that you're interested in. And does someone raise their hand? Is there a question already, or okay, I guess not. Uh, Also, this talk covers a year period, so some of the material is a repeat from last time that I presented, and I'll go over that material fairly quickly. There's a fair amount of new interesting stuff that's happened just in the last 3 months since I gave this talk in October. But some of my references go back to some of the major conferences that I learned things at in September. A lot of stuff from Embedded Linux Conference in Europe and from Plumbers. So this is the kind of the high level list of areas I'm going to go through. Again, in the kernel and the technology areas, some of this is repeat, and I will kind of cover that quickly. But let's start with the Linux kernel. So the latest Linux kernel is 6.13 RC7. This is the Linux kernels from the last year, and actually I probably could have taken 6.7 after off of this list because it's been over a year since that one. But we are in the release candidate 7, and so if everything goes normally, I haven't seen anything that would change this. We would expect 6.13 to be released this Sunday on the 19th of January. That means the merge window for 6.14 would open on Sunday. So just a few days, we'll see a bunch of new commits coming in from the different subsystems, and we'll kind of get an idea what will be in 6.14. And you'll notice that the time period is very, very consistently 9 weeks for each kernel release. Jonathan Corbett said something very interesting at the Open Source Summit Japan. He had a page that showed that in the last 13 years, we've only had 2 kernel releases that were longer than 10 weeks, which is pretty amazing. And both of those were exceptional cases. One, I think, was a power outage in Oregon where Linus Torvalds lives, and the other one had to do with a big security. I think it was the which was it? The not Heartbleed. Anyway, one of the big security things caused some extra time for that release. But so it's very, very consistent. You can practically set your watch by how long a kernel release takes. Going all the way back to that one in January, just a few of the things that were in that release were that you can enable or disable 32-bit emulation on x86 64 kernels from the kernel command line. So that was kind of interesting. And that was mainly just to reduce attack surface to prohibit 32-bit execution of 32-bit applications. And then the Itanium architecture was removed. There was more efficient kernel same page merging. And I've got links in this document. I'll send a PDF of this after the event so that you don't need to be writing down all these URLs. You can go see the information either in the kernel documentation or I get a lot of articles from lwn.net. You'll see that on these pages. Also in this release, the PrintK supported per console locking. And that allows a high priority message output to take over the console from a lower priority message. This is an important feature gearing towards acceptance of the preempt RT patch. In 6.8, which was a March 2024, so a little under a year ago, about 10 months ago. We had deadline servers added, and I'll talk about them a little bit in a second. We had the first real Rust driver was added to the kernel, and that was a reference driver for ASICs PHYs, and the physical connectors for a network driver. And then we had the networking core data structures were refactored for better cache efficiency. And we had the slab memory allocator was removed. So we got ourselves down to just one memory allocator, or slab type memory allocator of allocator of objects in the kernel. There's other page allocators and things like that, but and then the perf data type profiling was added, and that was actually pretty interesting. So deadline servers, I talked about this before, but this is a way to prevent real-time tasks from starving normal tasks, and replaces the real-time throttling feature. And basically what it does is it sets up a server to go and detect this starvation, or when the starvation is detected, the deadline server is activated, and the server can run the normal tasks so what happens is if the real-time tasks are taking too much of the CPU, you can end up starving everything else on the server. And so you want to always reserve a little bit of the CPU for non-real-time tasks, even if it causes you to be a little bit later on your real-time. This is, if you've done your analysis properly, this shouldn't break your real-time guarantees. It'll just make it so that you don't starve your non-real-time tasks while still meeting your real-time guarantees. And so there's an article about this. You can read more about it. The other thing that was really cool in this release was the perf data type profiling. And so this is a new subcommand on perf that actually allows you to annotate individual fields in a data structure. And so it can show you the offset of the structure fields and the frequency of access. And this is very, very useful to see if how the fields can be rearranged to improve cache performance. So you try to put all of your hot fields in the same cache line. And so this new perf subcommand allows you to do that, to see what are your hot fields, which ones are you're getting the most cache hits on. And when you line those up, you can improve your cache utilization quite effectively. In the Linux 6.9 release that was in May, the ext2 file system was marked as deprecated. So an ext2 file system could still be handled by the ext4 code, but the whole separate set of code that was ext2 only was removed. So the kernel continues to deprecate older systems. There was faster timer setup, and that is explained in that networking in the lwn.net article. There was work on reducing the network stack contention. Kernel energy model can be updated at runtime, and there was mitigation for register file sampling, which is a vulnerability on the Intel Atom core. So a lot security fixes and that type of thing. So getting to 6.10 in July, we had continued improvements for Rust support. And I'll talk a bit more about Rust because it's starting to come on strong. But anyway, there was encrypted interaction with the TPM, so some security things. So the kernel could interact with the TPM and do so in an encrypted way. So things that if you had bus sniffers, you wouldn't be able to see some of the communication there. And the crypto stats was removed. There was a whole subsystem that was keeping track of statistics on the cryptography subsystem, but apparently no one was using those stats, and so they just got pulled out. And then we also had the removal of some of the early alpha CPUs. And so things are going into the kernel, but they're also coming out. Another thing that happened was in this release, the 6.10 release, was memory allocation profiling. So there's some new code in the kernel that keeps track of which sections of code are allocating stuff. It's very, very handy to debug memory usage inside the kernel. And it should really help with people who are profiling the kernel. And we'll see another pattern in this talk about profiling and how important that is becoming, and some new features for that in later kernel releases. Now, in the kernel 6.11 release, we saw a new power sequencing subsystem that allows the kernel to bring up systems in the right order to have the best power utilization. There was a sloppy logic analyzer, allowed you to use the kernel as a kind of a poor man's logic analyzer if you had fast enough GPIO lines. And it's actually just kind of built into the kernel, so that's kind of interesting. And then a new runtime const macro. And I found this one pretty interesting. It optimizes the use of values that are determined at boot time and never changed, and it converts those into hard-coded instructions, which is faster. Right now, this is only used in one place. You can think of this as kind of the kernel recompiling or rewriting a portion of itself. It's rewriting kernel code at runtime for high performance. That's quite interesting, I think. Um, so yeah, I have a lot of opinions about why don't you just let the compiler do that? And well, it turns out that you want these common kernels that you have a single kernel image that can run on multiple systems. It detects a value and then it rewrites itself at runtime to use that value in the most efficient way. Okay, coming also in the 6.11 kernel, which was released in September, we had a new implementation of the get random function call. There's the VDSO for that. VDSO is something that's kind of a kernel function, but it's implemented it's accessible directly from user space. And this should speed up random number generation. It means that you do not need to actually go through the system call interface to get a random number. And I guess if you have an application where you're getting a lot of random numbers, that overhead can add up. The other thing, okay, so this is in red there, we see something that was not added. So there was a lot of talk over the summer about adding the extensible scheduler class. That was not merged in the 6.11 release, and it was actually merged in the 6.12 release. There was a lot of discussion about that. And now coming up to 6.12, this was quite an exciting release. Preempt RT was finally submitted and enabled. Well, it's submitted and it's available to be enabled. The last of the print K improvements went in for that, and I'm going to talk more about a whole lot about the Preempt RT patches later. There's a security module subsystem can now use static calls instead of indirect function calls. So anytime you're doing indirection in the kernel, it requires adds some overhead. And that was actually the runtime const feature that I talked about. That was a case of removing an indirection in the kernel with some static constants. The security module does something similar. It has the ability to replace at runtime the indirect functions calls with static calls. So a lot of stuff lately about the kernel rewriting itself. The tracing ring buffer can now persist across a reboot, so you can have some tracing data, and if you happen to get into a crash, it's possible that that can be in a buffer that you can look at on your next boot. So that's actually very useful. And then there's the integrity policy enforcement security module. That's more security attributes, or the security subsystem has some new ways to enforce things. In terms of this SCED-Ext, the extensible scheduler class, that was added in this release, the one that was not added in 6.11. This was added in 6.12, and it supports pluggable schedulers using BPF. And here you can see me talking about, it was there was a lot of debate about it going in and a 3 month delay. It finally actually did get integrated, and it's already being used for a lot of scheduler research and actually for some production code. So I don't know how much this will show up in embedded, but um, there's a lot of well, let's see. Yeah, I think I took out the page on this, but there is a lot of people talking about BPF schedulers at Plumbers. A lot of cloud servers or search engine providers. You can think of one popular one, Google. Uh, when they have these dedicated workloads, they have very specific scheduling requirements, and they can get a 5 or 10% increase in scheduling performance because they have it tuned to their workload. It's quite a big deal. Um, and so there's a lot of work going on this, and there was a whole micro conference on this topic at Plumbers if you're interested in that. The other news about 6.12, and this is actually really recent, is this was selected by the Civil Infrastructure Platform for its next SLTS release. I saw this on LinkedIn from Kobayashi-san. It's not listed on the CIP wiki yet, and there is a blog entry out there on the CIP project website that looks like it's got some good information. But you have to be a subscriber or something. You have to be a CIP member. I couldn't read the blog entry, but maybe I assume that after some amount of time that'll become available for anybody to read. But that's actually very exciting. So this is a commitment, I believe, to, well, it says in the title of this blog entry that 6.12 will have 10 years of support. So that is pretty exciting. They don't pick new SLTS releases very often. So this is really exciting. Now, 6.13. So just a couple of things here. So the ARM64 can now run Linux in virtual machines under the ARM Confidential Compute architecture. That means we might be seeing a lot more ARM64 cloud servers, depending on the types of workloads you might put in the cloud. But that's very interesting. So a little bit capability to have them be separated very nicely with the ARM confidential compute architecture. ARM64 is also gained support for user space shadow stacks, which is a nice security feature to deal with return-oriented program attacks. The lazy preemption patches have been merged, and I'll talk about those in a minute. There's a new thermal threshold system was added. So user space can now get a notification over Netlink when a particular device temperature crosses a threshold. And it can be when the temperature crosses either gets hotter than the threshold or gets colder than the threshold. So this will allow user space to monitor the temperature of devices in the system and deal with it either through, well, turning off devices or maybe adjusting the CPU, throttling the CPU, adjusting CPU frequencies, that type of thing. So this is pretty interesting. And then more Rust support was added. So there's actually now enough Rust support, in particular for the VFS, virtual file system data structures and interfaces. Enough support is in the kernel for the Rust implementation of Binder. And this was actually talked about at Plumbers and at other events. But this is there's someone who has actually implemented a Rust version of Binder, which plugs a whole bunch of security holes. The whole purpose of Rust is to address security issues at compile time that are not addressed by the C code. And so Rust is getting more and more popular. I'm going to back up a little bit and talk about lazy preemption. So I think we're going to see these types of features coming into the kernel as more and more people adopt the preempt RT patches. Now that you don't have to apply a separate set of patches, I think there's going to be a lot of this tuning work. I would put this under the category of tuning the kernel for both preempt workloads and preempt workloads. So this is lazy preemption is a new set of patches to do preemption better when you have a combination of throughput-oriented and real-time workloads. So if you have, you know, kind of, I don't know what you'd call it. Throughput-oriented is your classic, you know, workload where you want high performance on some like a database operation or something. But when you've got that same workload on the same machine, like you're controlling a laser or you're controlling some industrial process that has real-time demands, you want the best of both worlds. You want your throughput load to not be affected by the real time, and the real time to still get its um, still meet its deadlines. So currently in the system, when you have preempt RT patches in the kernel like we do now, there are four levels of preemption. There's preempt none, preempt voluntary, preempt full, and preempt RT modes. And so before you applied patches, you only had the first two, preempt none and preempt voluntary. So there is some voluntary preemption that happens in the kernel, even when when you don't have preempt RT enabled. And to support this, there are a bunch of places in the kernel that are instrumented with conditional reschedule calls. Those are sprinkled all over the kernel in places where you might have long running operations. And those long-running operations might interfere with real time. And essentially, those conditional reschedule calls, they're a form of voluntary preemption. It's the kernel telling itself, hey, this is I've been running for a while. This is a good place to schedule out if someone needs preemption. The problem with that is there are hundreds of these conditional reschedule calls, and they're inaccurate. They're not everywhere they need to be, and they are also probably in a couple of places they shouldn't be, and they're hard to maintain because there's hundreds of them. As the kernel changes over time, it's very hard to maintain these. So there's a new flag that has been added, which is a tasks flag related to scheduling. TIFF need reschedule lazy. The old flag was just TIFF need reschedule, and that was a flag saying alerting the kernel scheduler that needs to be rescheduled. But this new flag says, well, I need to be rescheduled, but it's not needed right away, so you can do it in a lazy fashion. And so there'll be a new mode in the kernel, preempt lazy, that will replace both preempt none and preempt voluntary, kind of a combination of both of those. And the idea is that what this new mode does is allows a lot of this instrumentation points to be removed. Thomas Gleixer estimated that about 95% of these conditional reschedule calls that are sprinkled all over the kernel can be removed. And so what that does is it means that there's less overhead for preemption points in the kernel when you're not using preemption. So this is actually something that allows kind of pseudo real-time behavior when you haven't turned preempt RT on all the way. It allows your throughput-oriented workloads, your classic workloads, to just run longer and better with less interruption. So that's actually very nice. It's lazy preemption. It has to do with preemption, but it's actually not for real-time tasks. This is to make normal workload tasks, throughput-oriented tasks, better, so that they run longer without preemption. Last couple of things in 6.13. So there's something called multi-grain timestamps. So some people want to know down to like the microsecond when timestamps have changed on files, but it's too expensive to put high-res timestamps on every file operation. And so there's a new system that is kind of a hybrid. It's a mixture of low resolution and high resolution timestamps. And what happens is the high-res timestamps are only used while they're being actively queried. So the data is kept in the kernel for the high-res timestamps, and while you're querying it, there's a certain time period during which you'll get back your high-resolution timestamps. But a lot of the low resolution ones are the ones that still go out to disk and get saved in persistent storage. So there's some certain applications that benefit from these high-res timestamps. They really tried to work to support the feature without causing too much overhead for everybody else. There's a new madvise operation to install guard pages. So actually users can now install guard pages on their own memory regions. So this is pretty nice. What happens is if a guard page gets accessed, then the kernel, well, the hardware will give you a signal, SIGSEG-V signal. So you can control memory ranges much easier, add some security of your own around your own memory regions. The riserfs file system was removed, and F2FS continues to be added to the kernel and continues to have kind of interesting features added to it. F2S is the flash-friendly file system. It now supports a feature called device aliasing, and it allows a portion of the block device to be temporarily used by another file system. I have no idea what the use case is for this, but I believe it's Samsung engineers added this. I believe they're allowing the file system to be used temporarily by something else in the system. I'm not sure what that something else is, but it's interesting. I don't know of any other file systems in Linux that allow that. Last thing, I think this last thing, yeah, that was added in 6.13 is support for auto FDO, and FDO stands for feedback directed optimization. Auto FDO and propeller. So there were two new makefiles added to the build system for the 6.13 kernel. So we're seeing a lot more work for automated optimization of the kernel. So Auto FDO allows for perf and MPU information, the performance unit measurement tools in hardware. That information can be fed back into the compiler. So the next time you compile the code, you compile it with a profile that corresponds to your workload. So how this works is you build the code, you run it and gather data using perf and a profiler. You take that profile and then you recompile the code again. And the important part is you're running with a very specific workload. The interesting thing about Auto FDO is it can handle slight variations between the code profiled and the new source code. So you can take the profile from like, say, 6.13.1 kernel, and even though there have been changes to the code, maybe you're on a 6.13.5 or 6.13.20 or something code, the compiler knows how to deal with those variations, and you can recompile with a profile from a different kernel version and still get optimization. So this helps with things like function inlining. It records which code paths are hot. It puts hot blocks together for better cache utilization. It improves your branch fall through. Does better register utilization. All of those things can add up to higher performance. And again, if you're a cloud server or special, if you're like one of the top 10 supercomputers, squeezing out an extra 2 or 3% performance through this optimization is quite interesting. So another type of optimization tool is called Propeller. Propeller is a little bit different. It still uses profile information, but it actually analyzes the binary. And it actually looks at intermediate representation transformations. So it looks at the actual assembly code. It takes the binary code, converts it to assembly, converts that to an IR form, and then uses the profile information to do some adjustments. And then it also goes back and then recompiles the code. There's another tool called Bolt that does something similar, but it doesn't use the compiler and linker. So Propeller uses the compiler and linker to actually recompile the code. Bolt can actually take the assembly code and it will relink after doing just some movement of code around. So quite interesting. Anyway, you can see in the documentation under Dev Tools, you can see the new information about these these new build systems. Obviously, when you're compiling the kernel, you need to add profiler data and that type of thing. So that's quite interesting, I think. I think we'll see a lot more of that. This is just the list of kernel releases. You can see that we're currently on, as of this week, we're on 6.13 RC7. We expect a 6.14 release very soon, probably this Sunday. You see the long-term releases, which are being supported for the next few years. Some of these will drop off soon. The new support term for kernels, for the long-term kernels, is about 2 years, unless someone picks it up for longer-term support. In terms of contributions by embedded Linux companies, I take a look at the last year worth of commits by a lot of these companies. This is ignoring stuff by like Intel and Qualcomm and even Red Hat, because they're not embedded. But there's not a ton of processor stuff on here, and some GPU stuff is missing. AMD is not on here. But this gives you an overview of commits since January 2024, which companies are kind of active in terms of commits and what kind of stuff they're working on. The stuff in red is different from the last presentation I gave. Excuse me. So we see ideas on board. Umeng Jain did some stuff with the Raspberry Pi GPU. Tvertko Ursuline did AMD DRM GPU driver support. Lenaro, Christoph at Lenaro is always the leader. Those commits, by the way, are for Lenaro. Christoph, I think, had about 1,500 commits, which was actually a little bit lower for him. But he was working on general cleanups, regular struct things, PM domain stuff. Thomas Gleixner was working on timers a lot of timer work and debug objects inside the kernel. Uwe Klein-Koenig did a lot of platform driver cleanups, and Xiaolei Wang's first time I've seen him in the list. Not a ton of patches, but he did some ST micro Ethernet fixes and some memory leak stuff. So that is kind of what's going on. You see a lot of Qualcomm processor, MediaTek processor work, AMD GPU stuff. So there's always driver and processor work going on. Just by the stats for this for releases I now get from the kernel source database. If you're a subscriber to lwn.net, this is a nice resource. But the 6.13 stats, there were 1,964 developers and 12,812 non-merge commits. And here's the charts. You see that we're actually down a little bit from the highest. We're not in danger of really going any time lower. It'll be really interesting to see. This includes the 6.13 merge window. Number of developers is holding pretty constant, right around 2,000 developers per release. And we're seeing, somewhere between 13,000 and 15,000 commits. So that's pretty consistent. It kind of goes up and down. We've seen a couple of releases where it's been a little bit lower than in the past, but we'll see what happens with 6.14. We'll get the new stats for 6.14 in a couple of weeks. Anyway, nothing to be alarmed there. Oh, just a couple of miscellaneous things that were commented on in the last little while. So Linus had on the mailing list was talking about the use of passive voice in commit messages. He doesn't like it. But he was quite polite about it. So a lot of times when he corrects people, sometimes it's not as nice. He's actually been quite good about being kind of less harsh with people. But basically, when you're doing a kernel commit message, make sure you use the active voice, which is a direct verb. This may not make as much sense in Japanese, but instead of saying, such and such was fixed. That's a weird way it's not a weird way to phrase it, but it's kind of it's the passive voice, and they don't really like that. It's a little bit vague and ambiguous. It's much better to be just direct, saying this fixes a null pointer dereference. And Linus, like I said, was quite polite about it. He said, I would love to see people doing this the right way anyway. And So that's just a reminder about commit messages for the kernel. A documentation request. So Jonathan Corbett removed a file in the documentation called documentation don't diff. This is a file that was used before the Git era. Now we have Git ignore files that kind of serve the same role. Um, but this was used for performing diffs on the kernel source tree. He ended up updating a bunch of documents in the kernel source tree into the process tree, 5.posting.rst document, and several translations of this. And what he kind of stumbled onto was that there's some translations in the kernel source tree that really could use an update. In particularly, he mentioned documentation translations, JA underscore JP submitting patches. This is I don't know if there's anyone interested in doing documentation updates for the Japanese language. This document was last updated in 2011. And I think this is I don't even think you have to do a good translation. I think if you submitted any kind of translation that just kind of brought this page up to date, you just have to look at the English submitting patches and kind of rewrite the Japanese version of that document. A relatively easy way to get a patch upstream. This was originally done by something called the Linux Japanese FAQ project. And I had to actually go to the web archive, the Wayback Machine, to see that this project is no longer active, apparently. I'm kind of wondering whatever happened to that. But I think that would be a really nice thing if we could resurrect some of these translations. So there you go. There's Tim's suggestion for something that someone in Japan who speaks Japanese can do. Some easy patches for the kernel. Uh, Another couple of things. These are a couple of patches that are in flight. These are just interesting because it's kind of a cross between legal, well, it's not technical issues really at all. There were two issues that came up with modules and kernel loadable modules and symbols, GPL symbols. So one was a patch that limits symbol access to specific Linux kernel loadable modules. So the kernel already supports putting exported symbols into their own namespaces if that's desired. And there are two namespaces now, two default namespaces. The default namespace, which is all symbols that are exported, and then the GPL namespace for symbols that are export GPL. So this new patch actually supports exporting symbols in its own namespace. So that was a feature that was available before. But the new part is that it's only accessible to a specific named kernel loadable module. So you can actually say these set of symbols, I only want to export them to this module. And so that really kind of tightens down the access to particular symbols. To some degree, I'm not sure how much I agree with this. This is intended to prevent symbols from being used arbitrarily and incorrectly, but it's a little bit like the kernel developers are assessing the copyright derivative work law of various nations. So they're doing armchair lawyering. Not sure that's great, but it's something that's coming, I believe. And there's another set of patches that is handles a very specific issue that came up, which was that Tuxedo Computers has modules that have a GPL v3 license, which is incompatible with the kernel's GPL v2 only license. And in their modules, they listed the license as just GPL, which I suppose is accurate. Well, but not really, right? So GPL v3 and GPL v2 are quite different. Well, they're not super different, but they're different enough that you really can't combine them. And so there's a new proposed set of patches that allows the kernel to specify by name modules that it believes has incorrect or misleading license declarations. It will not load. Well, I don't know if it prevents them from loading. I know at least it taints the kernel. So couple of patch sets. These have not been adopted into any kernel yet, but they are out there kind of pending to address concerns with people kind of messing around with the license for loadable modules. Okay, so that's the kernel. And I'm gonna go, I got a lot of material to cover. I'm gonna do it kind of a lot faster. So a lot of the material that I'm covering here comes from Embedded Linux Conference Europe and also from plumbers. And if you follow these links, you can search for presentation. The slides and the videos are available for almost all of this material. So boot time talks, there were some good ones at actually, this one was actually not. This was not at Embedded Linux conference, but it was by Red Hat at one of their own developer conference. And then there's some talks at Plumbers and my own talk at Plumbers and boot time reduction. So some of the current work that's going on with boot time is TI is working on Texas Instruments is working on streamlining firmware startup code. And they really want to generalize the handoff of firmware initialized hardware to the kernel so that it's not duplicate initialized. You can see what Qualcomm's working on deferred memory initialization. Red Hat's working on a NITRAM FS and reducing UDEV rules, high priority boot sequencing. I'm working on boot markers. Collabora is working on some stuff. Um, this is what I want to get to, though. So there is a new boot time special interest group. This is a new initiative to coordinate boot time reduction activities, and it's being led by me. I used to be the chair of the boot time working group in the CE Linux Forum and in the Linux Foundation Core Embedded Linux project. So we're actually planning to write a new boot time tools and tricks guide. We're having our discussions on the Linux Embedded at vger.kernel.org list. We have a monthly conference call that I've started up. The next one is in January 28th. I'm sorry for the time. The time is convenient for US and Europe. It's not a great time. I think it turns out to be 1 a.m. for Japan. But if there's enough interest from Japan, I can hold another call at a different time. So if you are at all interested in this, send me an email or contact me on LinkedIn. My email address is tim.bird@sony.com. It's pretty easy. There's a bunch of stuff going on. There's patches in flight. We've set up a boot time data repository. This is a separate repository. It's also a wiki, but it's a separate repository that has boot time data. So runtime data collected from a bunch of different systems, and we're doing boot data analysis on a bunch of different problem areas. I'm always looking, even if you don't want to get involved in the SIG, if you're willing to run a script that will send me your boot time data so that we can analyze it, I would really appreciate it. There's lots of work to do. There's lots of things that can be improved with Linux boot time. And the more data we get, the better we can understand what the problems areas are and fix them. So again, let me know if you're interested in joining that special interest group. In terms of the core kernel, we already talked about there's a generic ring buffer for the kernel that was proposed. Not sure how much progress that's making. The runtime const I already discussed. But Rust. Okay, we should talk about Rust. I heard something very interesting. It's in yellow there at the bottom. But let me go through this slide. So Rust support in the kernel continues to improve. We actually have real drivers, and it's now possible to implement serious subsystems, not just individual drivers. The binder driver has enough support in 6.13. So the binder driver hasn't been converted yet, but the subsystems support necessary for it have been. So if you go back to John Corbett's talk at Open Source Summit Japan, he made a lot of really good points. So Rust in the kernel is now viable. It is possible to work on the kernel and do a driver in Rust. There are still lots of issues. So the language itself is not stable. It's still changing. The Rust compiler doesn't support all architectures that the kernel supports. So if you write a Rust driver, it might not work on all of the architectures that the kernel supports. You can't take Rust features and take them from newer to old kernels, so that's a problem for backboarding features and bug fixes. And we still need lots of infrastructure. There's still lots of interface code needed between Rust and C. So Jonathan Corbett predicted that binder, the first couple of things would be binder. That seems to be in progress. The Apple GPU driver and an NVIDIA GPU driver. But this is the thing that really caught my attention. I was at the Member Summit in California in November, and I heard Greg Kroll-Hartman say, Linus says the future of Linux is Rust. And I don't know how much to read into that. I'm going to read a lot into it, though. I think that means that Linus is quite serious about about supporting Rust going forward, and about supporting. I don't think C is going to disappear anytime soon, but I think we'll see a lot more Rust in the future. So that's just a FYI. Okay, so I'm gonna screen through some of these other ones pretty quickly. So graphics work, there's been some nice work on the Raspberry Pi GPU. Um, and let's see, Mesa 3D. There was a good talk about Mesa 3D, a good introduction to that at ELC Europe 2024. In terms of file systems and IO, there was a nice block IO speed up added in 6.9. Had to do with avoiding lookup overhead during issue side of IO ops. And you have to understand what's going on in the in the block IO system to understand what that means. But there's an article you can read about it. There was a good talk by Andrew Murray talking about how to maximize your SD card life, flash file systems. Let's see, some talks about networking. I'm not going to get into a lot of these. So mastering Ethernet drivers, talking about Bluetooth on embedded Linux systems. So those are good talks if you want to learn about that. There was a whole networking track at Plumbers, and some of the topics they covered were buffer bloat and high availability seamless redundancy, reducing the overhead of network virtualization. So if you're interested in that, I recommend looking up those sessions. In terms of Linux power management, there was a really good talk in Embedded Linux Conference on this topic, talking about all the different ways that you can deal with power management in Linux. And in particular, there's a proposal by Stephen Boyd for something called an SoC power management driver. So there's lots of power management features in the kernel, but Stephen is proposing that there actually be a type of driver that is just a power management driver, and that you have a driver on a per SoC basis, so that you have a whole set of code that just knows how to deal with a particular SoC. So a pretty interesting proposal. This is, I would call, a category of kind of restructuring the code to take it away from generic to have a specific code for specific SoCs. Another couple of things. So the power sequencing subsystem, I talked about this earlier. This handles the problem where resources need power before they can be detected. And the device tree doesn't do a very good job of handling bring up ordering. It's just kind of ad hoc. And so this is a system to deal with that. It's being proposed by Bartosz Kozlowski. Okay, so real time. Again, I apologize. I'm going really fast through this technology areas, but there's some other things I hope I have time to get to. So what's left in preempt RT patches out of mainline? Well, nothing. Well, not exactly, but almost nothing. The final enabling patches were accepted for 6.12. The patch set was in development for 20 years, and there was a big fancy ceremony they did when Thomas Gleixner handed the pull request. He wrapped it in gold and tied it with a bow and presented it to Linus Torvalds. And then he also sent an email, of course, because that's how Linus wants to receive his pull request. But that was kind of a fun thing to do. Okay, so there are still some things out of tree, some ARM and PowerPC patches, some remaining PrintK tweaks. There will always be some stuff under development for any subsystem. This is real time is kind of not the same as other subsystems, but there's always going to there's like a real time next tree where things are in development, bug fixes are coming in, and so there's work that continues. There's finding bad lock constructs, removing the per CPU lock. And make sure that you report bugs when you're using this so that they can address them. There's a good, if you are interested in the history of Preempt RT and kind of the status, there's some talks that were given at Kernel Recipes. This was after Plumbers, I believe. So what's next? So there was the real-time micro conference at Plumbers with a bunch of talks about kind of the next directions. There's I think we'll see some tools developed to analyze real-time behavior of applications. One tool already exists, RT-eval. Um, and there's a lot more work needed on thread starvation and priority inversion. Specifically in 6.13, there were some fixes to avoid non-RT workload starvation when running preempt RT. And also there's the lazy preemption work, which is somewhat related, different set of patches, but somewhat related to that. And that as they remove conditional reschedule, that process is probably going to take several kernel versions. Coming up in 6.14, I've been told that there are also additional improvements in RT overhead reduction. So the work just continues. The kernel, the important thing is that the kernel now has preempt RT, but apps will still continue to make kind of real-time mistakes. So it's not enough for the kernel to have real-time support. The apps have to make use of the kernel properly, right? So you have to do things like locking down your memory, setting your CPU affinity so your real-time tasks don't bounce between processors. There's a whole bunch of things that in order to make your application work properly, you still have to do a lot of techniques. And so I think the future, we're going to focus on continuing to eliminate real-time bugs and making it easier for app developers to write RT safe code. So that's writing tools to detect and debug RT problems, and also just documenting the best practices, Linux art, real-time techniques, and the best practices. I think there's a lot of documentation that needs to be written. Um, let's see, security. There was a whole system boot and security micro conference at Plumbers, if you're interested in that. There was a really good status update on kind of which compilers and which tools, languages supported what types of security measures. And so shows you that kind of unexpected integer wrapping is something that's broken on both GCC and Clang. So shows you the areas that are good and medium and being worked on and things that are going well. Let's see, there was a good talk on board farms at ELC, and there was a whole microconference, testing microconference at Plumbers. I gave a talk actually on adding benchmark data to KTAP. I've already talked about this, so I'm not going to talk about it again. But if you're interested in testing, in particular testing benchmark data, let me know. Let's see, the kernel devs are talking to the toolchain devs, which is good. So we continue to see, well, like the auto FDO stuff, I think that's an LLVM thing. It might be a GCC thing, I'm not sure. But anyway, a lot of this optimization stuff is coming about because toolchain developers and kernel developers are talking to each other, which is good. There's a whole toolchain track at Plumbers talking about this, right? So you can read about Bolt and the feedback-directed optimizations, compiler support for security features, that type of thing. Tracing, let's see, it's a patch set for, the persistent tracings across a reboot. That was, looks like that went into 6.12. And there was a good talk on tracing tools, Perfetto tracing tools, that's usable for both Android and Yocto, given at Embedded Linux Conference. So the latest Yocto project, getting to build tools and distros. Again, I apologize for going so fast. Latest Yocto release is 5.1, which is called Styhead. That was released in September. This is not an LTS release. It's a bug fix release. The LTS release is Scarthgap, which is 5.0. So it's just a general bug fix release. There was a fair amount of documentation and reference manual fixes, and you can see the release notes there. There are actually a lot of good resources. If you are new to Yocto project, there's a lot of online training, and they have, if you go to the events section of their website, you can see, if you're just getting started, there's a lot of or if you want to see updates, what's going on with the latest releases of Yocto. And Buildroot also had a release in November, just a bug fix release. You can look up some of the security issues that were fixed with that if you go to their news site. Okay, so that's technology areas. Again, I said this was a little bit thin on this in the last 3 months because we didn't have a major embedded Linux conference. But anyway, so in terms of industry news, let's keep moving along. So there's trade associations and just kind of miscellaneous stuff. So the Linux Foundation has a number of projects that are related to embedded automotive grade Linux, civil infrastructure platform, core embedded Linux project is shutting down, unfortunately. There's drone code, ELIZA, kernel CI, OpenChain, OpenSSF, and the Octo project. Some of those I've already talked about. I talked about CIP selecting 6.12. Automotive grade Linux, actually, this is relatively new material. So there was keynotes from Honda and AGL at Open Source Summit Japan. That was just the end of October. And so if you kind of want to see what the status of AGL is, Walt Miner gave a really nice just kind of roadmap update. And there's the link to that. The Royal Rice Fish was released in July. That's kind of the old news. But Super Salmon is coming up in February, and he talked a little bit about some of the features that are coming up in that release. They use the alphabetical adjective slash fish method of naming their releases. So we went from R to S. Okay, so I have to just comment on this one because I was involved in this one. Enabling Linux and safety applications, the ELIZA. There's a new aerospace work group. The work group is not new, but what is new is they actually have a big focus on doing some work for what they're calling space grade Linux. So there was a workshop hosted by NASA in December, and the presentations and videos for that were collected and will be online, should be online soon. I would watch this page. They're not available on that page yet, but I think that's the page where they'll show up. They've actually created a Meta SGL repository. So they're going to create a Yocto. The intent is to create a Yocto distribution for space missions. And they're right now the placeholder name is space grade Linux. So they're trying to copy what automotive grade Linux has done. So this is how things start. This is a group of people, and I'm kind of in the middle in the back there in a red shirt. But this is a group of people that got together to start space grade Linux. And we were at the NASA. This is at one of the visitor centers there, and the models of the Hubble telescope, and they showed us around. NASA was a very good host. But this is how these things get started, just one meeting at a time. And so it's very exciting, I think. There's a lot of interesting stuff going on with space. Independent of my presentation on embedded Linux, there were two major heavy vehicle launches this week. Two lunar landers were launched on Wednesday, one from Japan and one from the US. So a lot of exciting stuff going on in the space area. Finally, just some miscellaneous items. These are just kind of all over the map, but might be of interest to you. So there's the OSS Developer Support Pledge, Intel and Tech Stocks, and NVIDIA Linux-based. I say laptop here. Actually turns out it was desktop, but I'll talk about that. So there's this problem that people don't think open source developers are getting enough money. And so several people have been trying to solve this problem. One is that just came out in the fall here was this pledge. A bunch of companies have committed to pay $2,000 per year per their own company engineer into a fund that helps OSS developers. So the amount of money that you would pledge is based on your own engineering staff and how much you think you're how much you think you're using open source, how much value that's giving your project, your products. I don't know if this will take off, but they have raised over $2 million. So they have a list, I think, of about 15 or so companies that made this pledge. So that's interesting. I think it would be good to get money, companies can support open source a lot of different ways. One is just to fund the developers directly, the external developers just with money. Another way, of course, is to contribute the time of their own employees. But sometimes companies don't do that last thing. Sometimes their own employees are kind of too busy with the company focused efforts. And so this is an alternate way of kind of supporting the ecosystem. There have been other methods. People try to fund this. Another one, this was not really last year, but the year before, in 2023, Bruce Perens announced something called the Post Open License, which would put new, not open source projects because there was money tied to it, and it didn't have the same licenses, but it was a way to fund shared development of code that could be shared freely. So that's an interesting another interesting way to do this. So that's just to let you know that there are people looking at this issue. I've heard a number of people with this idea that companies should commit some portion of their engineering budget to help external non-employees. So that's interesting. Okay, so Intel and tech stock worries. So Intel lost $16 billion in 2024, and I don't say this to rag on Intel, but the Intel market cap at the end of 2024 was $82 billion. Meanwhile, and it used to be, I think it used to be over a trillion. It used to be in the hundreds of billions for sure. Meanwhile, the Nvidia market cap at the end of 2024 was 3.5 trillion. It's like way high. So Intel's way low comparatively, and Nvidia is real high comparatively. That's just kind of interesting to see market flips like that. I think Intel is still a crucial company in terms of embedded Linux and just Linux support in general. There's a lot of concern in the US about the predominance of what's known as the Mag 7, the Magnificent Seven. These are the seven top tech companies in the world, and in particular in the S&P 500. So the Mag 7 stocks now make up about 31% of the value of the S&P 500 index. And this has nothing to do with embedded Linux, but if you're an investor, these index stocks that do an index of the entire market, it's a little bit frightening to have only seven stocks. There's a lot of people's retirement accounts tied up in index funds, and it's heavily reliant on just a few companies, which is concerning. Um, I don't have any more to say about that. Just something a little bit interesting. Oh, the other thing was at CES, NVIDIA announced something called Project Digits. And this really doesn't have, this is a desktop computer. Sorry, I put laptop on the other page. This is a desktop computer. It's a $3,000 device containing a GB10 Blackwell chip and a 20-core CPU based on ARM architecture. And it has 128 gigabytes of unified RAM. Unified RAM means that it's available for both the GPU, that GB10 is a GPU, and the CPU, and supports up to 4 terabytes of storage. So basically, this is an AI model cruncher. This is a desktop computer, and the reason I have it here is because it is a Linux computer. It's runs what they're calling DGX OS. This is a derivative of Ubuntu Linux. It's a Linux desktop computer specifically targeted at running AI models. So an individual one of these desktops, they claim, will be able to handle models with up to 200 billion parameters. And there's a way to link two units together to handle up to 405 billion parameters. So I'm not an AI guy, but apparently those are good numbers. And so I'm not doing this as an advertisement for NVIDIA. I'm just saying that it's quite interesting that we're seeing Linux-based devices really starting to take over the AI world. I think we'll see that in both at the desktop level. We're certainly seeing it. I mean, all of these large language models are being run on supercomputers that are running Linux. So we're seeing Linux at the supercomputer. We're seeing Linux in AI on desktop computers, and I think we'll see Linux and AI running on embedded as well. And we've already seen that. So that's not much of a prediction when something's already happened. A couple of community things, and I know I'm kind of getting towards the end of my time here, but a couple more things. So a couple of kernel community issues cropped up just recently that you might be interested in. They're kind of concerning, but and then we have some conferences, and I'll talk about the eLinux Wiki. So in October, some kernel maintainers were removed in kind of a weird way. And then there was a code of conduct penalty that just happened inside the kernel community. So in October there was this big what I'm calling a kerfluffle, kind of a lot of people got upset about the removal of Russian Linux maintainers from the kernel maintainers file. And there's two articles there you can read about it. So what happened? Well, so what happened was there was a patch that removed, I think it was about 11 maintainers. But the patch was delivered in kind of a secret way. It was not put on kind of the normal mailing list, and there was not a lot of explanation about what it was about. So this caused a lot of people to get upset and worried that maybe something weird was going on, or they're discriminating against Russians because of their nationality. There were lots of complaints about the lack of explanation. There was lots of speculation and misinformation about the scope of the change and what the reasons for it. It turns out it was not a removal of all Russian nationals, but a specific set of individuals who happened, most of them, not all of them, most of them had Russian email addresses, and so that's kind of why it gave the impression it was about their I don't know, ethnicity or nationality. But it was specific individuals who worked for specific Russian companies. So not all Russian nationals were not removed. One maintainer was reinstated after showing evidence of a different employer, and it later came out what this was all about. So what this all was all about was U.S. sanctions. So the actual legal advice, or I don't know if you'd call it a policy, but this was something that James Bottomley dug up, and it seems to have come from the Linux Foundation legal team. But here's the new policy. If your company is on the US OFAC SDN list, I'll explain that in a sec, subject to an OFAC sanctions program or owned controlled by a company on that list, our ability to collaborate with you will be subject to restrictions and you cannot be in the maintainers file. So you probably don't know much about the structure of the US government, especially these types of things. But the OFAC SDN list is the Office of Foreign Assets Control Specially Designated Nationals list. So OFAC is part of the U.S. Treasury Department, and it manages the list of foreign entries that the U.S. has sanctions for. So since the U.S. and a number of other countries, the U.S. was not the only one, actually has a list of companies that have sanctions on them. And in this case, it had to do with Russian companies. So it was not about individuals at all. It would just happen to be that these individuals worked for companies that the U.S. had sanctions. Now, the problem is Linus and Greg, they do not have the option to just ignore U.S. law. If the U.S. law says you can't provide certain benefits to a foreign entity if they're under U.S. sanction, you can't just ignore that. You could face fines and penalties and possibly even jail time. So there's a lot of, you could disagree with the US's policies or their sanctions, but Linus and Greg just kind of have to do what the Linux Foundation lawyers tell them. The Linux Foundation lawyers kind of have to do what the US government tells them. So there's a good description of the policy here. Some other people made some good comments on kind of how this happened, why it happened. And if you go to the Phoronix site there, so hopefully that puts your eye on mine. There was a lot of people worried that other countries would get targeted, and that doesn't appear to be the case. It was just a specific set of companies. The other thing that happened that was quite interesting was there was a code of conduct penalty. So in November, the LF Technical Advisory Board imposed a ban on a single individual kernel developer. So the restriction was to decline all pull requests from that developer. The developer was involved with the Bcache FS file system. That was the affected subsystem. So it's important to note this ban is temporary. It lasts one release, so it means it's a ban of about 2.5 months. And so the ban is just to decline pull requests. It didn't kick him off mailing lists. It didn't forbid him from going to events or anything. Um, it was based really on just an unfortunate email exchange. There were some harsh words exchanged, and the Code of Conduct Committee really wanted the developer to come back and just publicly apologize for their behavior. This penalty is very rare. So if you look at you can go back and look at Code of Conduct Committee. So the Linux kernel has a Code of Conduct Committee. I think there's 4 people on it right now. They've been there for years. And when someone issues a complaint, they look into it and they recommend a course of action. Most of the time, 99 times out of 100, the course of action is it's just resolved behind the scenes. They talk to the people involved. They get them to settle their differences. Every once in a while, something public needs to be done. Very, very rarely. In fact, this is the first time I can remember it in like the last maybe 10 years. Is there an actual penalty involved? So this is a rare thing. You can read up more about it on this lwn.net article. I think that the long-term effect of this will not be bad. A lot of people disagreed with the Code of Conduct Committee and the Technical Advisory Board, but in the grand scheme of things, a temporary ban is not that bad. Just means some patches might be delayed. The developer did apologize, and he seems to want to continue working in Linux after the penalty expires. He put up a blog kind of giving his side of the story. And so anyway, I think it will die down, but it is interesting. We do not see this very often in Linux. People are very well behaved. Linux has got a reputation for being kind of a harsh environment, but it's not a harsh environment these days. People are fairly friendly and fairly professional. Not fairly, they're very professional. All the developers I work with are very professional. Okay, last on to conferences. So we recently had the Open Source Summit Japan, and I'll talk about some conferences coming up soon, and then Linux Plumbers coming up. So Open Source Summit Japan was in October, the end of October in Tokyo. There were lots of great presentations. I highly recommend, if you're interested in the kernel, to go look at John Corbett's keynote, the kernel report. And there's the video is online for this, so you can watch the full video and see the topics. He talks about Rust. He talks about SkedgeX. He talks about the direction of the kernel and stuff. There are pictures, the schedule, which has the presentations and the videos. They're all online. Usually the video link and the presentation link are on the page for a particular presentation, which is available from the schedule. So you can see the post-event report. It was a great event with lots of great material there. I really enjoyed it. I had a lot of conversations, hallway conversations behind the scenes, talked to a lot of people. Some of the conferences that are coming up real soon is FOSDEM, February 1st and 2nd in Brussels. Embedded Recipes is coming up in Nice. And unfortunately, there's a conflict here. Linaro Connect is coming up in Portugal, Lisbon, Portugal. So those are some of the embedded conferences. And then over the summer, coming up a little bit later in the year, we've got Open Source Summit North America with Embedded Linux Conference. I think last time I said we weren't sure if we were going to have Embedded Linux Conference there, but we are. We're going to have it. And we've got the CFP, the call for papers is open right now. So you can go, and the deadline, I should say, the deadline is coming up. It's the middle of February, so don't delay. You've only got about a month to submit something for that event. And so Open Source Summit Europe is coming up in August. They're a little bit close together, which is disappointing, but we'll have Open Source Summit North America in June, Open Source Summit Europe in August, this time in Amsterdam. We're planning a big celebration for the ELC 20th anniversary. That's right, we've been doing Embedded Linux Conference for 20 years now. So this is weird. The CFP, the CFP for both events, for both ELC and ELC Europe, is the same CFP. We've never done a single CFP covering both events. We're not sure how well it's going to work. The main reason for that is the events are so close together. We thought it would be weird to have two separate CFPs, but maybe it was a bad idea. We will not know until we look at this. We'll have to see. So if you're planning on coming to either of these events, make sure you look at the CFP and get your proposal in. We'd love to have you come present something on embedded Linux. Okay, and then conferences in late 2025. So we've got Open Source Summit Japan, which is moving back to December. And we've got Linux Plumbers Conference, which is coming to Japan. I think the last time it was in Japan was over 10 years ago. So this event will be Thursday through Saturday in December. So both events will be at Toronto Hills, just like last year's Open Source Summit Japan. This is a big deal to have plumbers coming to Japan. We're very excited about it. I'm on the plumbers program committee or the planning committee. So I just want to make a couple of comments here. So hosting in Japan is an exception. The normal pattern is to alternate between US and Europe. And we are worried a little bit as planners. We're worried about the number of attendees and sponsors. So please help us promote the event in Japan and Asia. We know that there are tons of Linux developers and embedded Linux developers in Japan and in Korea and in China and Taiwan. And we're hopeful that we'll get a lot of really great technical content and technical content that sometimes we don't normally hear. We want variety and diversity. So LPC is a weird combination of, it's kind of a kernel developer staff meeting. It's kind of where the kernel developers talk amongst themselves, but it's also a place for non-kernel developers to come and give their requirements. It's for contributors and users to get learning opportunities about kernel subsystems. So we are looking for sponsors for Linux Plumbers. The prospectus is available now. It was just came out like last week. So if you are interested, some of you I know, and some of you I'll be contacting if I have your email. Watch out, because I'm nominally in charge of kind of rounding up sponsors in Japan, but I'll be working with other people in Japan to do that. But we're looking for sponsors for LPC, and we're looking to heavily promote that event. I think it'll be great to have plumbers in Japan next year. Well, this year. It's this year. It's December of this year. So, the last thing is the eLinux Wiki. It's in transition. We have a crowdfunding site for it. We're still trying to decide how to use the money we've got for it. A lot of the areas of the site are out of date, but we still keep, there's a lot of material with my boot time SIG. We're keeping all of our boot time information on there. Would love to see other groups keep their embedded information on there. Hardware companies keep a lot of good content on there. So please use the wiki and please contribute to it. So in conclusion, hope I did the right amount of time here. I don't know exactly how much time I was allotted, but overall, we're doing great. Embedded Linux is widely deployed and it's functional. There are literally billions of devices running embedded Linux, phones, TVs, routers, and all kinds of other both consumer electronic systems and industrial control systems, civil infrastructure systems, all kinds of systems running embedded Linux. The core kernel systems are in place. New hardware keeps being made. I can't believe we're not done yet, but as long as there's new applications for Linux, space grade Linux is a new field of endeavor. Not really. Linux has been used in space before, but it's been used by SpaceX. But it'd be great to see NASA and ESA and JAXA also using Linux in their space projects. And so there's always new work to be done. It's always exciting to be involved with embedded Linux. And so with that, I'll give you my list of resources. This is where I get a lot of my information from. And please check embeddedlinuxconference.com for up-to-date event information. And then Phoronix and LWN.net, of course, I get a ton of material from them. Including if you want to learn something about the kernel, please see the LWN.net kernel index. This is the best place to kind of learn about a particular kernel subsystem or a particular kernel feature and kind of what the current status is and what the history is. And with that, I will say thank you for your time, and I will take any questions.
Thank you. はい、質問ある人いますか？質問ある場合、マイクを使ってほしいので手を挙げてもらえますか
？Hi team, thank you for your great talk. I'm Hirokishi working at Panasonic, and I work for Agile project. And what I want to share you is that recently Agile project had decided to drop ARM32-bit support soon because it became very hard to support, for example, for Flutter support, keep Flutter support, and many other things. So So how do you think about it? I mean, in general, are we going to drop ARM32-bit support soon? By Linux kernel or any other open source, or maybe there is still some usage for that.
Yeah. So okay. So I will. I don't think the kernel will drop ARM32 support very soon, but I do see some problem signs. So I heard the other day, I can't remember where I saw this, but I saw that I think Scarthgap, which is the Octo project, has dropped support for a few ARM32 boards. I think they dropped support for the original BeagleBone, which is quite disappointing. And I can understand why some of the major projects are dropping support if it's difficult. But we did a poll 2 years ago in Plumbers. So in Richmond in November of 2023, we did a poll at the Embedded Linux BOF. We had a Birds of a Feather session at Plumbers, and some of the ARM maintainers were in the room, and they actually asked the question: is ARM32, is anybody still using ARM32? And like 70% of the audience raised their hand and said, yeah, we're still using it. So I think we sent a pretty clear message that there's still a lot of people using ARM32, and I hope it doesn't get removed. But yeah, we do see stuff drop out. The best way to keep stuff alive is to keep reporting about it on the mailing list. So so if you have projects where ARM32 is still being used, make sure you talk about it. Make sure that the upstream developers know that you're using it.
Yeah, thank you. Yeah, actually, I was a bit surprised. There are still so many users for ARM32-bit, but yeah, thank you.
Yeah, thank you.
はい。他何か質問コメント、はい、どうぞ。
Hi, my name is Hiroshi Tokita. I'm working at Fujitsu, and I joined the Zephyr project development. I expect for Space Linux project, Space Grade Linux project, and I heard Japanese space exploration startup Space Cubic Sun is already used Zephyr in the satellite. So Oh, and their satellite is involved the explosion in last month. Launched from Wakayama, Kushimoto, and the launched rocket is explosion. So
Oh,
involved
yeah, that's
their
great.
satellite. So and we expect. We expect to use the open source ecosystem to space exploration and space development is great to our futures. Thank you.
Oh, that's great. I need to relay that to Kate Stewart, who is involved with the Zephyr project. She'll be quite she may already know about that. Yeah, I'm excited to see Zephyr used in space. Um, so Sony was involved with the Slim mission. We were involved with the Sora Q little rover that was like the shape of a softball. That was using NutX, which was open source. So yeah, there's opportunities for open source. Some of the systems are not using Linux, but I think it's very exciting to see open source, whether it's Zephyr, NetX, or Linux. I think we'll see more of it in the future, so that's exciting.
That was the NatX rover is sold at a Japanese toy shop as
Yes.
very cheap toys, and
Yeah.
that is already belong reached to the moon. So
Yeah.
Zephyr is chasing it. So it is our big challenge, I
Yeah.
think. But
Yeah, so Sony asked me, well, so Sony asked Frank and I if we could get Linux on that particular chipset. So it was a Sony semiconductor called S Presence was the
oh,
main chip on that. And we
oh.
we tried, but it was so small we couldn't get Linux on it. But it was still neat, even though Sony also does a lot with
Yes,
NetX.
yes, yes, yes,
I
yes.
wish Sony did more with Zephyr because I think Zephyr is quite an interesting OS.
But NatX is also great OS.
Yeah.
Yes. Thank you very much.
Yeah, thank you.
はい、他何かありますか？いいですかね、時間もちょうどいいぐらいなので。OK, thank you, team.
Okay. Yeah, thank you
はい、
very
じゃあ、
much.
はい、じゃあ拍手もお願いします。Thank you. はい、じゃあ、